Hello all, welcome to Tutlings. In this tutorial, we will see how to deploy a vlang API that is powered with a vweb framework and that talks to a PostgreSQL database on Google Cloud Platform on Cloud Run. So without further ado, let's get started. In our previous tutorial, we have seen how to deploy vlang-based REST API on Azure platform. The detailed tutorial and the link for that is here. And I have also created a detailed article to help you understand how to deploy this application on Azure. But this application used to talk to SQLite database. But today we are going to see how we can just make our application talk to a PostgreSQL database that is deployed on Google Cloud Platform as a Cloud SQL database instance, establishes the communication from the REST API to the Cloud SQL Postgres database. For the sake of demonstration purpose, we will clone the same repository, which I have already done here on my local PC. So we need to make few changes for this application so that it can talk to the PostgreSQL database instead of SQLite database. The first thing is we will make our changes on a branch, which will be named as vweb Cloud Run. So for that, I'll be checking out a new branch. So once I'm done with that, I'll import a PG module, which comes as an inbuilt module when you install V programming language. So as we no longer need SQLite, so I'm removing the reference to SQLite. I'll replace the SQLite module with PG. And the way that we need to connect to the database instance with the help of PG module will be different. So we will just go ahead and update that using this code. So here we can see that the database variable, which is a mutable variable, is holding the reference to the Postgres connection, right? So here what it is doing is it is connecting to the Postgres with the arguments that we are providing here in the form of environment variables. The first argument is the host, and the second one is the user. The third one is the password. The fourth one is the database name. And the fifth one is the port, which is of type integer for this port. So with that in place, as we have these environment variables that are being read from the OS module, let's go ahead and import OS module. So we need a way to read these environment variables from env file. So for that, we need to install a package which is zztkm.v.env. So this is a very popular and stable module that is available to install through V Package Manager or VPM. So to install this package, all you need to do is copy this command and run it on your terminal and hit enter. So as I have already installed the module on my PC, it is showing as updating the module. Alright, so once I am done with that, all I need to do is import the reference to zztkm module by using the command import zztkm.v.env. Alright, so with this setup in place, I'll go ahead and try to create a env file for development purposes, and I'll be naming it env.develop. In this file, I'll be going to add few environment variables which were referred here. So these are the environment variables that I have added here. So on my local PC, when I'm working on my local PC, these are the values for this respective environment variables, right? So when you deploy this, you have to create the environment variables with these names as a key and the respective value for these environment variables on Google Cloud Platform in Google Cloud Run. So we'll see that next steps. So with this setup in place, we have to do one last change, which is um, HTTP port, which is hard coded as 8080, and we will leave that to be read from the environment variable. But if you want that, you can also go ahead and define it here as 8080. All right, so with these changes in place, we need to build this application as an image. There were few changes that we need to make for our Docker file because it's no longer only dependent on SQLite, but it is actually dependent on PostgreSQL as a backend database, right? So for that, we need to install few modules. So I'll be going ahead and cleaning this file and pasting the contents here. So there are two layers in this Docker file. Let me just maximize this code. So here we can see in the first layer, which is a builder layer, I'm setting the application's home directory and I'm installing the necessary modules that will help me build this application and also install this package from the V package manager. And then I'm moving all the contents of V app to app directory and I'm formatting the application code and then generating the build executable from my app that is present in the app directory, which is identified as the directory name here. In the second layer of the Docker file, which is titled as prod, the outcome of the V app will generate an executable. I'm copying that to the current layer's home directory, which is code. And in that, I'm actually issuing the entry point, which is like .app, right? So I'm directly executing that. But before that, I'm exposing this port 8080 and setting the environment port as 8080. And I'm also installing few modules that are required for me to help run this application. The first one is CA certificate, which will help me expose these ports and establish the TLS connections. And the second one is libpqdev, which will help you to interact with the PostgreSQL database. So that's all about these two layers that are present in our Docker file. All right, so with these changes in place, what we'll do is we'll go ahead and build this image and see if it builds successfully. All right, so for that, all I have to do is to issue this command docker space build space dash t, which is a tag vlang API, and the location of the Docker file will be dot. So let's call this something like for Cloud Run. That will be the tag, right? So I'll go ahead and hit enter. So meanwhile, this gets executed. Okay, we have this error. Okay, so we have imported zztkm.vdotenv, but we have never loaded the environment file, right? So for that, all we have to do is load this environment develop file using v.env.load, and the argument will take .env.develop, which is the name of this environment file. All right. So if at all you have any production environment file, you can also create that, right? So for example, if you have .env, which is the prod env file, right? So let's say, for example, port for the Postgres is 5432, you can just mention, and you can refer that specific environment file here as well with comma separated value like this. So with that in place, let's format this application. All right. So this application code is formatted and then let's build this. So, all right. So we don't need this because it's no longer SQLite database. Yeah. So it is building the image. Meanwhile, this builds the image. We can go ahead and do some setup. All right. So let's go back to the Cloud Console. Here I'm on the Google Cloud Console, right? So there are a few things that you need to enable in order for you to deploy the vlang web API onto the Google Cloud platform. So here are the services that I have enabled. The first thing is you need to enable compute googleapis.com, run.googleapis.com, and then optionally you can go ahead and enable container analysis, and you must enable cloudbuild.googleapis.com, and then finally you need to enable a service named sqladmin.googleapis.com. So how you do that? You can go ahead and search for API and services, right? So here in the first result, click on this, you will be landed on this page and click on enable. And here you can search for something like SQL admin, and you will see the enable button if at all it's not enabled. So as I already have enabled this, I'm seeing manage. So with this minimum API and services enabled, I'll go ahead and land on SQL. So I already have created a SQL instance. Typically, it takes more than 30 minutes for you to create a SQL instance. And this instance is of type PostgreSQL, right? So if at all you are interested in understanding how to create a Cloud SQL PostgreSQL instance on Google Cloud, you can refer to my video, which I have already created. The link for that I'll leave in the description of this video. So once I created this instance, there are few things so that I can access this Cloud SQL from my local PC. For that, I have to go on to the details of this Cloud SQL instance in connections. All I need to do is capture my IP address and paste it here in the add network, something like my PC and value. As I already have pasted this, I'll just go ahead and remove that and ensure that that change is still there. All right, so I'm still having that value. So which means that I will be able to access this Cloud SQL database instance from my local PC. So the next thing is we will be creating a database in this database server. For that, what we'll do is we will take help of PG admin and we'll connect to this Cloud SQL database instance by clicking on register server. And let's call this GCP, yeah, Twitlings DB. This could be any random name of your choice so that you can identify this. And the host will be the public IP address of this database instance, which is this. And the port will be default. I'll leave it as is. And maintenance database username is something that you can find here, which is defaultly Postgres. And if you want to change password or forget password, ensure that you will generate a new password or give the new password accordingly. But when you are changing this password, ensure that if your database server is already tied up with any other existing applications, that might break. So you might better want to choose this step carefully so that you can, once you regenerate the new password or change your password, you reflect the same on your all the dependent applications. As I already have given the same password, I'll go ahead and give the same password here and I'll save it and click on save. So I should be able to successfully establish the connection to this Cloud SQL instance, which I did just now. All right. So I see that there are 5 databases in this particular database server, right? So for the sake of demonstration purposes, what we will do is we will create a new database, which will be termed as vlang API DB and click on save. Okay. So what we can do is, let's see if we can just delete this and recreate this database. All right. So at this instance, when we look into the tables for this database under the schemas, we will not find any table, right? So it has no tables at all at this moment. So once we deploy our application, we will be able to see a notes table, which will be created by our application based on the code that we have written in our application as shown here, right? So what our application doing is like it is trying to create a table node and that node table is having this schema as mentioned here. All right. So we have successfully able to create the image out of our code. So what we can do is let's do one thing. Let's commit these changes. Right. So I'll go ahead and add git and all the changes that I have. Right, let me check. All right. So this is what I have, and this is a optionally I have this environment and Dockerfile. All right. So even before I commit this, as we are planning to deploy our application to Google Cloud Run, and I want this application to be deployed in automated fashion. By that, what I meant is I want to enable continuous delivery for my application. For that, I can go ahead and add a cloudbuild.yaml file or a ML file. So whose contents will be like this, right? So this is a very simple code to understand, though it looks very hard to read, right? So I'll explain you in a very simple fashion. There are hardly three steps which you can diversify based on the ID till the name. The first step in this cloud build YAML file is build. The second one is push, and the third one is deploy, right? The first one is the build step, which actually builds the application code using Docker, and it will give you the tag based on the nomenclature that is mentioned here, and based on the Docker file that is available in this root directory, which is this. That's what the build step does. The second step is the push, right? So the push means once the image is created from this first step, the push step will actually pushes the image to the cloud storage within the same project. And you can identify the image based on this nomenclature, right? The third step is deploy step. So based on the instructions that were mentioned here, it will try to deploy the image that is pushed onto the Google Cloud Registry, gcr.io, and it will try to run the application even before pushing using this command, using the Cloud SDK, and it will deploy this image to a service that is created on Cloud Run, and the image, which is the image that we have created in the previous steps, and it is instructing that image to be pushed to this deployed to this cloud service, and the region which will be created when we create a Cloud Run, and that will be auto populated by the Cloud Run itself, which we will be going to see in few minutes. And these environment variables are standard environment variables that will be auto-populated once we have the Cloud Run enabled with continuous deployment, right? So with these changes in place, I'll just stage all the changes one more time. And what what we can do is let's switch back to our original format, and we can just go ahead and commit with a message vlang vweb API on Cloud Run GCP. All right, this is some intuitive message, and let's push this. All right, so all right. So once the changes are pushed, all right, they are already pushed, and let's navigate to our repository, which is this one. We will see vweb Cloud Run. All right. So this is our repository, and let's ensure that we have cloudbuild.yaml file, we have Docker file that is just modified and deployed, pushed few seconds ago, and we have everything in place. All right, this is good. So let's copy the name vweb Cloud Run. So the next thing we are supposed to do is navigate to the Google Cloud Console and click on Cloud Run, and we will be creating a service in a Cloud Run by clicking on Create Service. As I want to continuously deploy my application as and when there are changes, right? So this is the option I choose, which is continuously deploy new revisions from a source repository. And we will click on Setup with CloudBuild, and you will be greeted with this side navigation pane titled as Setup with CloudBuild. All right. So I have already granted my Google Cloud Platform the access to my GitHub repository because GitHub is the provider for the source code that I own. But in your case, it could be like Cloud Source Repositories or Bitbucket. You can choose accordingly. So I have also enabled access to the vlang API, which is this application, Vincent/vlang-API, which you can see here, right? So I'll go ahead and click on next. And the branch that I want to uh, deploy onto is vweb Cloud Run, which is the branch that our application code is pushed onto and is latest, right? So with that selection in place, we will choose the build type. Currently, you don't have an option to select cloudbuild.yaml file, which is actually available here. We have just pushed here, but it will automatically get selected over the period of time once we create this service. So we will see that in a couple of minutes. So for now, let me select the Docker file. And if your source location of Docker file is something different, then you can give that relative path of your Docker file. But in my case, the Docker file is in the root directory. So I have given the relative path of my Docker file. So I'll go ahead and click on save. All right. So the next step, what I'm going to do is I'll leave this service name automatically picked up by the Google Cloud Run service as is. And there are various regions that you have options to choose from, right? So I'll go ahead and select the US Central one, which is defaultly selected. And CPU is only allocated during the request processing. Yeah, I'm fine with that. And I would like to have only 4 maximum number of instances in order for me to enable auto scaling, like because of the demonstration purpose. So in this, yeah, I would like to allow all traffic, and I would also like to enable allow unauthenticated invocations for my service that is running on Cloud Run. Next, we'll go ahead and proceed with configuring container properties, connections, and security. The first thing is the container. So we will be exposing the port 80 on the container instead of 8080, and I do not have any container commands and container arguments, so I'll leave them blank, right? You have the various options to enable startup CPU boost, which I can let you choose. If you want to, it will work too. So you have various options to choose from: the capacity, memory, and the CPU. All right. So the request timeout is 300 seconds, and the maximum request per container is 8, which is the concurrent request that you can have per container. And the execution environment, you can just enable or choose any of these generations. I'll go ahead with the default. The next step in our uh, container configuration journey is adding environment variables, which is very crucial for us. So here in our app directory of our code, we have had various environment variables. The port is actually being automatically picked up by the container on Cloud Registry. So we leave that and fill all the 5 environment variables as described here. So the first thing is PG host, and the second thing is PG port. Let me click. And the third one is PG user. The fourth one is PG password. And the fifth one is PG database. All right. So now we'll go ahead and fill the values for port, PG user, which will be the user that we have already created by default, and the password for the Cloud SQL. So these are the values that you can find here on the Cloud SQL instance, right? So in our database, so this is the place where you can see Postgres and the corresponding password. PG database. All right. So the database is something that we have just created, which is vlang API DB, right? So let's go ahead and give that value here. vlang API DB. Let's ensure that it is correct. vlang vlang API DB. All right. So here, when it comes to PG host, the way that you are supposed to provide value for this is / Cloud SQL / followed by the instance name of your or the connection name of your database instance. So you can find the connection name here. Just copy that and paste it here, right? So it must be prepended with / Cloud SQL /, right? So we are done with this container configuration. The next thing is connections. As our application is dependent on Cloud SQL database instance, which is PostgreSQL, we must authorize our application to establish connection to the Cloud SQL instance, right? So this is the connection name, and we should allow or add connection such that you will find this in the drop down, right? So this is a connection, and you can just choose that and let this app service communicate to this Cloud SQL instance, right? So I'll leave the default options in the security tab. And with that in place, we will go ahead and click on create. So what happens once I click on create is it will create a CloudBuild trigger based on the configuration that we have given here, right? So let's look at what happens behind the scenes. So it is setting IAM policy and it is creating a placeholder revision, which is this, and it is enabling the routing traffic, and it is creating a CloudBuild trigger, which has successfully done and completed, and it is building and deploying from the repository. These logs are the build triggers logs. So let me see. So this is a CloudBuild option. All right. So here I'm on the CloudBuild. So here we are on the triggers page. This is the one that we have just created. And this CloudBuild trigger is associated with our Cloud Run service vlang API, and it is Cloud Run managed. And the events are whenever code is pushed to this branch, which is this branch, this build trigger gets invoked, right? So the source is this one, which is on GitHub, Winson/vlang-API, and this is the branch which is the service is configured to deploy the code from. And currently it has identified the CloudBuild configuration YAML file because it is able to find that YAML file. Earlier we have chosen Dockerfile, but automatically it has changed itself to the configuration type of CloudBuild configuration YAML, right? So here, as we have discussed in our CloudBuild YAML file, there are various environment variables, right? So such as service name, host name, project ID, these were automatically populated by Cloud Run when it creates a continuous deployment with the help of CloudBuild for us, right? So as it's already created, so let's go to the history. All right. So I see that it has successfully deployed, and this is a build history, right? So it has just passed building the application, right? So these are the four steps, three steps that we have in our cloudbuild.yaml file, as we have just learned a while ago. The first one is build, the second one is push, the third one is deploy. All right, so build, push, and deploy, or build, push, and deploy, and the respective logs for each of those build steps, right? So congratulations, the build has succeeded, and the application, which is the Cloud Run service, is showing green status. Now, all we have to do is just click on the URL so that we can access our application, right? So there is a default route in our application, which is in we can app.v, welcome to Tutlings. And this is what we see. And let's see, we have nodes endpoint to REST API that will allow you to perform CRUD operations on a entity named node, right? So we do not have any nodes right now. We can just go ahead and run few commands by, all right. And similarly here, right? So for that, let's open the terminal and git bash, because on Windows, git bash is the only terminal that will allow you to run curl commands. And I'm just sending the request to these two uh, post requests. So now I have two nodes added on this Cloud Run service. And let me refresh, or like let me relaunch this and navigate to nodes. Ta-da. So let me access the node by ID. Yeah. So go to schools and let me see if I access the node that does not exist. Yeah, not found. All right. So far so good. And let's verify our database, as we have seen that even before deploying the application, we did not have any tables. So let's go ahead and create that refresh. Now we will find this table that is actually created by the application for us. And let's look at the data here. And we will see the two records that we have just created with the help of curl command on our git bash terminal, right? So get the status of the college applications and go to schools, all plurals. I don't know why I have changed something in the meanwhile. All right. So yeah, that's all about it. And what we can do is test the continuous delivery, because I specifically wanted my application to be enabled with CD features, which is continuous delivery. So for that, all I can do is just go ahead and welcome to Tutlings vweb Cloud Run deployment demo, right? So our default endpoint, which is the default route, shows currently welcome to Tutlings. Now I want this to show the new message which I'm about to check in right now, right? So all I need to do is stace that change, commit that change, test continuous deployment on cloud using CloudBuild, and push those changes. All right. So what will happen now is our build, if you look at the history, the trigger is configured such that whenever there is a commit that happens on this branch, right? So vweb Cloud Run. it will automatically deploy those changes, right? So let's look at the build details as and how it succeeds. And once this is deployed, I expect to see a different message that we have just pushed. All right. Yeah, now it's deploying. Okay, so it took 2 minutes, 10 seconds to uh, build this complete check-in, right? So it has successfully deployed also, which is indicated by the message as well as the icon. So I'm excited to see the new message. All right, congratulations. That's all about it.
I hope you definitely found this video helpful. In such case, please do give it a like and share it with your friends. Please do subscribe to my channel and hit the bell icon. Have a great day.